Plastic is everywhere. Our toys, computers, and food containers. It's strong, light, and incredibly useful. But this convenience comes at a cost. Plastic doesn't go away. Unlike an apple core or paper, plastic resists decomposition. A plastic bottle can linger in the environment for hundreds of years. Nearly every piece of plastic ever made still exists somewhere on Earth. It fills landfills and invades forests and oceans. Wildlife suffers. Sea turtles mistake bags for jellyfish. Birds get tangled in plastic rings. Microplastics, tiny fragments, contaminate our water and soil. This pollution threatens animals and humans alike. We created a material that's too good at lasting forever. Now, we face mountains of plastic waste with no easy way out. Scientists worldwide are racing to find solutions. They're searching for creative ways to break down plastic, and surprisingly, the answer might come from the tiniest forms of life. Imagine, could something microscopic help us clean up this mess? The story of plastic's downfall might begin with a single invisible hero. Let's discover how nature is fighting back. The plastic problem is huge, but hope is on the horizon. The solution could be smaller than you think. Let's see where this story leads. Consider this. Meet our unlikely hero, a bacterium so small you need a microscope to see it. This microbe has a superpower. It eats plastic. Not science fiction, real science. Bacteria are everywhere, and some are incredibly helpful. Now scientists have found bacteria that digest plastic. Nature is adapting, even to our toughest problems. These bacteria see plastic as food, not trash. Different types can break down different plastics. It's like assembling a team of tiny cleanup crews. Imagine using these microbes to clean up our waste. Special facilities could feed plastic to these bacteria instead of burying it. This is nature's solution to a man-made problem. Science is learning from nature to make the world better. The discovery of plastic-eating bacteria is a game-changer. If we understand them, we could revolutionize recycling. The adventure of finding these microbes is just beginning. Let's see how this breakthrough happened. The science adventure starts now. The breakthrough began in Japan, at a plastic bottle recycling plant. Scientists searched for microbes that might have adapted to eat plastic. They collected samples from sludge and wastewater, then brought them to the lab. In the lab, they exposed these samples to PET plastic, the kind used in bottles. After weeks of observation, something amazing happened. The plastic started to disappear. Under the microscope, they found a new bacterium doing most of the work. This microbe could use PT as its main food source. They named it Eidionella sakaiensis, after the city of Sakai. It was the first time a bacterium was found that could break down and live off plastic. This discovery proved nature was adapting to our pollution. The news electrified scientists worldwide. Suddenly, a new hope for tackling plastic waste was born. The search for more plastic eaters was on. How does a tiny bacterium eat tough plastic? Eidionella sakaiensis uses special proteins called enzymes, nature's molecular scissors. The process starts when the bacterium attaches to PET plastic. It releases an enzyme called PETase, which snips the long plastic chains into smaller pieces, called mHET. Then a second enzyme, mHETase, breaks mHET down into two simple chemicals, terephthalic acid and ethylene glycol. These are the original building blocks of PET plastic. The bacterium absorbs these molecules and uses them for energy and growth. In essence, the plastic is transformed into new life. This is recycling at the molecular level. The bacteria turn harmful waste into the building blocks of life. It's nature's ultimate recycling program. Microscopic, but mighty. The process reverses plastic manufacturing, closing the loop. This discovery opened the door to a new kind of recycling. Imagine, plastic waste, gone, thanks to a microbe's appetite. The next step? Making this process even faster and more efficient. Scientists are now working to supercharge these enzymes. Let's see how. The PTase enzyme was a breakthrough, but scientists wanted more. By studying its 3D structure, they learned how it cuts plastic. In a happy accident, a small mutation made PTase even faster. This super enzyme broke down P at 20% quicker than before. It proved we could improve nature's tools. Now researchers use AI to design even better enzymes. They can test millions of mutations on computers, searching for the fastest plastic eaters. The goal enzymes that break down plastic in hours, not weeks. Scientists have also linked PTase and mCTase together, creating a powerful enzyme duo. This team works faster, passing the job from one to the other. The result? PET plastic is broken down rapidly into its building blocks. This innovation brings us closer to large-scale, efficient plastic recycling. The future of recycling could be powered by these engineered enzymes. The possibilities are expanding fast. Let's see how these discoveries are being put to the test. Discovering plastic-eating bacteria in the lab is just the start. The next challenge, making them work in the real world. Scientists are building bioreactors, giant tanks where bacteria or enzymes break down shredded plastic. In France, a company called Carbios has already built a demonstration plant using optimized enzymes. They turn old bottles, food trays, and even clothing back into pure building blocks for new plastic. This creates a circular economy. Plastic becomes a resource, not waste. Other researchers are testing if bacteria can clean up polluted soil or water. Some fungi and even waxworm larvae have also shown promise in breaking down different plastics. Each discovery adds a new tool to our pollution-fighting kit. Nature offers many clever solutions. The race is on to scale these up for real-world impact, but challenges remain. Using bacteria to eat plastic is promising, but not a magic fix. The process is still slow. Natural bacteria take weeks to break down thin plastic. Engineered enzymes are faster, but need to be even more efficient for industrial use. Most current enzymes only work on PET, but we use many types of plastic. Each type needs its own specialized enzyme. There are also safety concerns. Releasing bacteria into the wild could have unintended effects. That's why most research focuses on using enzymes in controlled facilities. Cost and scale are big hurdles. Bioreactors and enzyme production must be affordable. We also need better systems to collect and sort plastic waste. Solving these problems will require innovation and global cooperation. The journey is challenging, but progress is real. Let's look at what the future could hold. Imagine a future where plastic never becomes waste. Instead, it's sent to recycling plants where enzymes break it down in hours. The building blocks are reused to make new bottles, clothes, or even medicines. This is the promise of infinite recycling. It could end our reliance on fossil fuels for new plastic, cutting greenhouse gas emissions. Plastic would become a valuable, endlessly reusable resource. Scientists are also exploring upcycling, turning plastic's building blocks into higher-value products, like vanilla flavoring. The field is just beginning. We've only scratched the surface of what microbes can do. Future discoveries could let us recycle mixed plastics or clean up ocean pollution. The potential for innovation is enormous. By partnering with nature, we can solve our biggest environmental problems. The story of plastic-eating bacteria is just the start. The future of recycling is bright, and it's powered by science and nature. We're on the brink of a new era in sustainability. The possibilities are truly amazing. Our planet faces a plastic crisis, but nature is offering help. Plastic-eating bacteria show that life can adapt to even our toughest challenges. For decades, our only solutions were to bury or burn plastic. Now, we can unmake it, breaking it down at the molecular level. This is recycling in its purest form, creating value from waste. But technology alone isn't enough. We must reduce single-use plastics and choose reusable products. Better waste collection and sorting are essential. Enzymes are a powerful tool, but prevention is even better. The story of these microbes is a story of hope and partnership. Science and nature together can heal our planet. The future is about learning from nature, not fighting it. By innovating and collaborating, we can build a cleaner, more sustainable world. Consider the possibilities.